Hello everyone, welcome back. In this video, we'll be discussing about the third problem of today's weekly contest, maximum number of alloys. The problem is a medium level problem just because of this particular statement. All alloys must be created in the same machine. So if you are like me who didn't notice this statement during the contest, this is your time. You can pause the video and try to solve this problem with this statement in mind. So with that, let's get started. The problem states that you are an owner of the company that creates the alloy using various type of metals. There are n different type of metals available, and you have to access 2k machines. Each machine requires a specific amount of each metal type to create an alloy. For the ith machine to create an alloy, it needs this much unit of metal of type J. Initially, you have a stock. Stocks of I denote the type of ith metal you have initially, and you are also given a cost array which will denote what is the cost to purchase 1 unit of ith type of metal. So in total you are given these things: n number of metals, k number of machines, budget, the budget that you have, and composition array. Basically each machine you have been given what is the composition of metal it requires to create an alloy, and you are given stock and cost which denote the initial stock that you have and the cost required to purchase 1 unit of metal if you want. So in total you need to return what is the maximum number of alloys that you can create within the budget of budget coins. So notice that the problem states all the alloys must be created with the same machine. So it is not possible for the company to use two different machines at the same time to create the alloys. So that's a very important part of this problem. So let's look at an example. Let's say n is 3, k is 2, budget is 15. Basically, we have 15 coins, we have two machines, and we have three metals. So composition says 111. So basically, first machine takes 1 unit of first type of metal, 1 unit of second type of metal, and 1 unit of third type of metal to create the alloy. 1110 is the second machine's composition. It says the second machine requires 1 unit to create 1 unit of first type to create an alloy, along with 1 unit of second type and 10 units of third type. So you have been given a stock. Initially you don't have any metal at your hand, and you are given cost which is basically to purchase 1 unit of first type of metal you require 1 coin, to purchase 1 unit of second type of metal you require 2 coins, to purchase 1 unit of third type of metal you require 3 coins. So it's as per the problem it says that this machine will be the optimal one which you will be able to create the alloy. Notice that you can't use both the machines at the same time. So you will create the alloy using this machine only. Now if you create the alloy using this machine only, you have total 15 coins at hand. So what you can do, you can purchase 2 unit of metal 1, 2 units of metal 2, 2 units of metal 3. So in total you have 2 units of each of the metal, and if you see you will be able to create 2 alloys with the first metal with that particular configuration. Now to purchase 2 unit of metal 1 you require 2 coins, 2 unit of metal 2 you require 4 coins, 2 unit of metal 3 you require 6 coins. 6 plus 4 plus 2, 12. So in 12 coins you are able to make 2 alloys, and you can see any other combination you will not be able to make greater than 2 alloys in less than equals to 15 coins. So hence the answer is 2. So hope the problem statement is clear. Now how to solve this? As always, I would encourage you to at least try the brute force solution by yourself before moving forward. So let's first look at the brute force solution itself. So we have been given this cost array which denotes okay, first of all there are 4 machines, M1, M2, M3, M4. There are 4 metals as well, and we have been given the cost of each of the metal, and we have been given the initial stock that we have for each of the metal. Now we have a budget of 55 coins, so we have 55 coins in hand, and we have to use this 55 coins to create as many alloys as possible. So what can be the brute force solution? So you know that you will only be able to use one machine, right? So the brute force solution could be, okay, I will try with each machine. I will see, okay, how many alloys I can create using first machine, let's say x1. Then I will say, okay, how many alloys I can create using second machine, x2. How many alloys you can create using third machine, x3, x4. So finally you will take the maximum of all of these to get your final answer, right? So what we are doing is we are trying to find out what is the maximum number of alloy that I can make using a single machine, and I will do it for all the machine and take the maximum. So how to find out the maximum number of alloys that you can make using M1? So one thing you can do is, let's just copy this over to make it clear. So one approach could be, okay, I will see if I can make one alloy using M1. If it is possible to make one alloy, I will see, okay, can I make two alloy? If it is possible to make two alloy, I will check, can I make three alloys? If it is possible to make three alloys as well, I will check, is it possible to make four alloys? If it is not possible to make four alloys, it means I can make three alloys, maximum of three alloys using M1. And 3 would be my answer for M1. Similarly, we'll find it for M2, M3, M4 and take the maximum and return the answer. So the problem statement now is how to find out whether I can make some X alloys from a given machine M, right? So let's try to tackle this. So can, for example, let's say we are talking about machine M1. So this is the cost and this is the stock that we have, and this is the budget. So can, let's say X is 4. So currently X is 4. So it means we are trying to check whether I can make 4 alloys from the machine M1 using this particular constraint. So what would be the approach? I would encourage you to pause and try to think this by yourself because this is straightforward. So we need 4 alloys, right? So in total, what we need? So we need 8 units of metal 1. We need 4 units of metal 2. We need 8 units of metal 3 and 16 units of metal 4, right? Because that's where we will, if we have this much, then only we will be able to make 4 alloys, otherwise not, right? Now we already have some stock with us, right? So we already have this much with us. So how much extra we want? So we want 7 unit of first metal, we want 3 units of second metal, we want 7 units of third metal, and we want 1 unit of fourth metal. Now we are also given the cost of each of the metal, right? So how much will you be will you need to spend to actually get these all metals in the stock, right? So you know that you need to buy one more first type of, sorry, you need to buy 7 type of metal 1 more, 7 unit of metal 1 more. So in total you will be spending 7 coins for the first metal. In the same fashion you will be spending 27 coins for the second metal. You will be spending 7 into 2 14 coins for the third metals, and finally you will be spending 8 coins for the fourth metal. So in total, how much coin you need to spend? 27 plus 7 34, 34 plus 14 48, 48 plus 8 56. So you need total 56 coins to actually make 4 alloys from the given metal M1, and you only have 55 coins. So the answer is no, right? So hope you get the intuition how you are trying to tackle this. Basically we are trying to find out how much metal I need to buy extra, and from that I can figure out what is the coin that I need to have to buy those metals, and I can simply compare the number of coins that I have and the number of coins that is required to figure out whether I can actually make the given number of alloys from a given machine or not. So what will be the time complexity of this entire approach? So what we are doing, we are first figuring out how many metals are required. So this is simply order k. This is order n. N is the number of metals. So this is simply order n operation. Now from there we are trying to find out how much we need to buy. So we are simply subtracting it from the stock. So again, this is order n, right? We are doing some subtraction for each element, and finally we are trying to find out what is the total amount of coin that I need to have to purchase these all metals. So that is again an order n operation, right? So in total you are doing order n operation to actually answer whether it is possible to uh, make some X alloys from the given machine or not. So what with the pseudocode? The pseudocode would look something like this. We will simply say we want to figure out if we can make this much alloys or not. So as discussed, we'll try to figure out what is the required budget that we need to have. So for that we figured out what is the total number of metal I that I will need, and what is the number of metal that I already have in stock. If I subtract that, I will get how much metal is required, how much metal of type I is required to actually make this much alloys. So from there I can figure out what is the total cost that I need to spend for on metal I. So if I just sum all of those costs, I will get what is my required budget. And finally, I will just compare the required budget with the number of budget or the amount of budget that we have, and simply say yes or no. Right now, this was not the original problem. The original problem was this, where we need to find out the maximum number of alloys that we can make, and for that we saw that we need to figure out whether I can make some X alloys or not. So using the function I can simply answer, I will call the function for machine 1 for X equal to 1. If the function return true, it means I can make one alloy from machine 1. I will try X equals to 2. That is, I am trying to say, can I make 2 alloys? If I can make 2 alloys as well, I will try 3. If I make 3 alloys as well, I will try 4. The first time that we get no, the number before that is the maximum number of alloys that I can make using that particular machine. So this is something we will do for all the machines and get some values for each of those and take the maximum to get the final result. Now what is the overall time complexity of this entire solution? The overall complexity is we are doing something for each of the machines. So there are total, let's say, k machines, right, as per the problem statement. For each of the machine, what we are doing, we are trying to find out whether one is possible. If how much time complexity is this? Order n. We have seen that. Now after that we are trying to see if 2 is possible, again order n. If 3 is possible, again order n. If 4 is possible, again order n, so on and so forth until some h, which is the highest number of alloys that I can make, right? So for h times, I am doing order n operation. So overall complexity would be order n into h for a single machine, and we have k machines, so overall complexity is k into n into h. Now k and n are given to us. K and n as per the problem statement is very small, 100. So this doesn't have any issues. What will be the value of h? H is the maximum number of alloy that you can make. So what is the maximum number of alloy that you can make using any machine? So the worst case scenario could be you just have one, you just require one metal. Again, this may not be possible because composition starts from 1, but let's assume that you require just one metal to make a particular alloy. Now you just need 1 unit of cost to buy that metal. So in total, how much how much this metal can you buy using this budget? Let's say budget is B. You know that you require just one metal to make that particular alloy, and the cost is also 1. So in total you will require, you will be able to make B number of alloys using this B budget, right? And if you have some, let's say, stock as well from before, let's say the value of this stock is again S, just assume, or S dash. So again you will be able to make extra this much number of metals as this much number of alloys as well. So in total, you are able to make B plus S dash number of alloys in worst case, in best case. So the stock that you have maximum is 10 to the power 8. The budget that you have is also 10 to the power 8. So in total, in best case, you will be able to make 2 into 10 power 8 number of alloys, right? Again, this is assuming that everything else is 0, but it's not the case. Everything else is also 1, so it will be much less than 2 into 10 to the power 8. But for now, this is a good enough estimate for H. Now you can see, if this is the value of H, the current solution will not scale. It will not pass the given time constraint for sure. So that's where we need to optimize this. Now notice that these two structure are fine, or these two things in the time complexity is fine. Only we need to somehow remove H. Now where from H is coming from? H is coming from the fact that we are trying to iterate over each of these number of alloys one by one. We are trying to check whether 3 is possible, whether we can make 3 alloys or not, and then we are trying to check whether we can make 4 alloys, 5 alloys, all the way up to H. So this is a linear search, right, for the number of alloys that I can make. If we can somehow convert this to binary search, this H would turn into will be converted into log of H, right? And the entire complexity would then be k into n into log of H, which is sufficient to pass the given time constraint because k and n are very small. So can I use binary search here? The answer is yes. Again, I have recorded a completely different video of binary search. If you are new to binary search, you can watch that. In general, if you have some sample space, in this particular case, this is, let's say, can I make can I make one alloy? Can I make 2 alloy? Can I make 3 alloy? So on and so forth. So for a particular, you will divide the array into half, right? In other words, you are saying, can I make X alloy? If I can make X alloy, if the answer is yes, and I am deterministically able to say that my answer will lie either in the left or in the right. So in that case, I can simply convert this linear search into binary search and get rid of this H and convert it to log H, right? So that's where what I will do for this particular case. Can I make X alloy? If the answer is yes, then do I need to search in the left half? The answer is no, because if you can make X alloy, you should be able to make X minus 1 alloy, X minus 2 alloy, X minus 3 alloy, and everything. And you want the maximum number of alloys that you can make, so you will not bother to search in the left half at all. Instead, you will only search in the right half, right? So you are able to skip the half array completely with just one question. In the same fashion, if you are able to, if you are saying that I can't make X alloy, the answer is false. So in that case, does it make sense to search in the right half? The answer is no, because if you are not able to make X alloy itself, you will not be able to make X plus 1 alloy, X plus 2 alloy, all the way up to H, right? So in that case, it is obvious to search in the in the left half only, and we can completely skip the right half, right? So in every scenario, we are able to deterministically say whether to go left and right, and hence we can apply binary search. So in total, we will be doing log h number of operation, and in each operation, we want to figure out whether I need to go left or right, and for that I need the answer whether I can make this X alloys or not, and for that we already know that we can answer that in order n time. So in total, you require order n log h to figure out how many alloys you can make for a particular machine, and you have total k machine, so in total you require k n log h time to figure out what is the maximum number of alloy you can make from all the machines. So if you have watched to this point, I would strongly encourage you to pause and try to code this entire thing and get it submitted in Leetcode as well, because that's the point you will understand what piece in the problem you have doubt about. So next we're looking at the code. The code is straightforward. We have this is possible function, which is exactly what we have seen before. We'll simply figure out how many alloys we actually need, and how many of them are in stock. The remaining we will buy. So we require this much cost. So this is the total number of coins that I need to actually buy the metals that will allow me to create this many number of alloys for this particular metal composition. So now what we are doing, we are simply iterating over all the machines. For each machine, I am doing a binary search. Again, the lower bound is 0, all the way to 20 to the power 8, right? And for each of them, I am trying to figure out what is the maximum number of alloys that I can make using this particular machine. And after this binary search ends, the L and R both points to the same value, which is the maximum number of alloys that you can make using the same machine, and you can simply take the maximum across all of them to get the answer. So if you have any doubts in this particular problem, feel free to post them in the comment section below. Now let's just look at one small follow-up. You can try by yourself. In this problem, we have been given that all alloys must be created with the same machine. Now the problem, if you remove this, is you will not be able to solve this in linear time for sure. So that's where let's just try to simplify this. Let's say there is no stock at all. Basically, stock of I is 0 for all I. There is no stock that you have. Now you don't have this constraint, and you have to solve this exact same problem. Again, let's say there is no stock, and you have to solve this exact same problem without this statement. So you can this is rather easy, not harder than what we have already solved here. So I would not reveal the solution. I would encourage you to think, and let's discuss the solution in the comment section below. If you have solved this problem in some other way, feel free to post that in the comment section below as well, so that we all can learn. So with that, I will end the video here. If you like the video, give it a thumbs up and do subscribe if you haven't already. And I will see you in the next one. Thank you.